All right, so here we go. So what we're going to show here is just the working principle of a current regulator. It's just a way to control the current from a source into a load in a way that with a current regulator you can convert impedance or translate impedance. So you can basically do that by using a pass device here. This is right here. And then what happens is you drive this, you either drive it or you drive it less to control the current. So what you do is you set up a voltage reference here, which right here just looks like a voltage source, but that would be like a Zener diode selecting a reference. Say it's 5 volts. Okay, here it's 7. And then the other is the voltage that is proportional to the current. So you use a sense resistor. Normally it'll be a lot smaller than this, but it generates a small voltage across it. And you basically convert that small voltage into a higher voltage that works within the range of your actual reference. And then everything over here, all of that is doing, that's a differential amplifier, and all it is doing is it's actually it's just actually basically just a differential circuit. It's just going from a differential input to a single-ended. So it's as you can see, the V sense voltage, that's right now it's 3.6 volts across that sense resistor. Okay, it's not 3.6 volts from this point to ground, because that is a lot different, right? Like if we put in a voltmeter right here across that, right, and you'll very quickly see that. And we rerun it here. See, it's 22.9 volts, right? That's not what we're after here at all. That's right, because it's taking the voltage across the sense resistor. So in order to be able to take that voltage and use it against the reference, you have to convert it to single-ended so that that voltage is with reference to ground. So that's how you do it. And so you're comparing the two, and you're basically trying to control this current, the load current, with this voltage. So, and obviously if there's anybody out there that is seeing this and can help me with current regulation, please, I'm happy to, any tips, but I'm working on this. And anyway, so the whole idea is right now how the loop is that we have a reference of 7, and you have to remember too that this is not a real feedback loop. This is kind of just in simulation. So, well, it is kind of a real loop. It's just that it can't regulate. The loop can't stabilize right now because of where the reference is and everything. But if it's 7 volts, that means that we have a reference of 7, and our voltage with reference to the current is 3.6. So it's saying our set point is at 7, but we're only at 3.6. So we need to drive harder, which is why the output of the op amp is basically at the rail, 23.9. So it's trying to drive that transistor, driving that aggressively so that it can increase the load current to create more of a voltage drop across the resistor, across the sense resistor, to balance the loop, right? So and the whole idea is by changing the reference there, you can control the current. So that reference would then be connected to a window comparator type of situation. Anyway, so we are going to now show let's see here. So that's how it loops. So what we're going to do is take the reference down below where it is, so 2 volts, and then rerun the simulation. And what is going to happen when we rerun it, it's going to be lower, so it's going to be driving the transistor less, because it's going to be saying, whoa, we're above where we need to be, let's drive the pass device less. And there you go. Now it's at 13 volts, right? And so it's driving less current. So that's kind of how it works. And that's basically a current regulator situation. It's an analog feedback loop, and all you're trying to do is get the sense to match the reference. And the tricky part is just getting that sense voltage into something that you can compare against the reference, because it is with the sense voltage is not a voltage with respect to ground. It's a voltage across the actual resistor. So that's basically all I wanted to show and all I wanted to document. And also, I guess that the fact that this whole differential setup is only here because there's no SPICE model for an actual, there's no SPICE model for the actual, let me show you, for this guy, right, which is an INA 180, comes in various, let's move this over if I can somehow. Let's move it, yeah, there we go. So yeah, so it's an INA 180, and basically what it does is it does all of the stuff in here that you need to, so that you can just put this chip across the sense and it will do real small stuff. So like this guy, right? Like this is what's showing up today for me. So it's like a, what the heck is it? Like it's a 200 micro ohm shunt basically. So at like an amp, it's like 320 microvolts or something like that, but it's going to be good enough. Well, it's going to be awesome, and it's going to work really good. So it gives you this version, the A2 version that I have, that I bought. What is it here? Oh, that's not it. Never mind. I bought the A2 version, which is this guy right here, the 50 volt per volt. And so you can see, just like there's the sense and there's the output, right? Single-ended. So that's how that's all gonna work. And yeah, I guess that's basically all I wanted to show today as far as this is working. Let's see, anything else I can review with this setup here is just in summary, this is how you control the current and translate impedance from a source to a load.